Now we're going to start a discussion on congruent triangles. We're going to learn what we mean when we say two triangles are congruent, and then we're going to look at some properties that if two triangles have these properties, that's enough to say that they're congruent. But first of all, what do we mean by congruent? Well, we mean that the corresponding parts of both triangles are congruent. In other words, there are three angles. They correspond to three angles in another triangle. If each of those corresponding angles are congruent, and likewise, each of the corresponding sides are congruent, we say that the two triangles are congruent. Now, let's look at an example here. I've got two triangles, LMN, this triangle here, and PQR, this triangle here. This angle L corresponds to this angle P. So I denote that they're congruent just by putting a little arc and a single line through it, just like that. So L and P are congruent. M, an arc through both of these. M corresponds to Q. Those angles are congruent. And notice the arc with two lines. And then finally, N is congruent to R, and I put three lines there on both of those. So each of those angles are congruent, and likewise the sides. This side corresponds to this side to this side, and finally the other side. Now, notice how I named these triangles. I have LMN and PQR. Notice angle L corresponds to angle P. That's the first letter. M corresponds to Q. And N corresponds to R. See? N and R. And then the segments. LM is congruent to PQ. See? MN is congruent to QR. MN and QR. See? And then finally, LN is congruent to PR. Okay, when this happens, you have congruent triangles. Now, what we want to be able to do is we want to look at four theorems that tell us that if you see this, you have enough information to say that those two triangles are congruent. Now, the first one is side, side, side. If you have two triangles and you know nothing about the angles, you don't know the measure of the angles, but you do know that each of the corresponding sides are congruent. So, for example, in this triangle, this side is congruent to that one, this side congruent to this one, and this side to this one. You don't need to know the measurement of the angles. That's enough to tell you that those two triangles are congruent. And we call that side, side, side. Now, another one, side, angle, side. Now, the order here is important. You've got a side, then an angle, and then another side, like this. See, here's a side, here's the included angle, and another side. See, it's not side, side, then an angle down here. It's side, angle, side. Side, angle, side. Whenever you see that situation, SAS, that's enough to tell you that those two triangles are congruent. You don't have to know what this side is. You don't have to know what these angles are. If you see side, angle, side in both of these, then you know enough to say that those triangles are congruent. Another one, angle, side, angle. Now this time, an angle, then a side, and then an angle. Notice it's not an angle this side and then an angle over here. It's the included side. Angle, side, angle. Angle, side, angle. If you see that, that's enough to tell you that those two triangles are congruent. You don't need to know anything else but that. And then finally, we have angle, angle, side. Okay? So notice this is not the included side. This is an angle, another angle, and then another side. Notice the difference here. This is the included side up here. Angle, side, angle. This is angle, angle, side. If you have that, then you have enough information to say that those two triangles are congruent. Now, we're going to kind of work in some proofs. And I want to show you how this works. See, let's suppose we have two triangles here. We have ABC. Okay, so here we go. We've got ABC, ABC, and then we've got DEC. And I want to prove that those are congruent. Now, I'm given a bit of information. I'm told that AD, this right here, AD, bisects BE. Now, when we say bisects, that means that it cuts it into two equal parts. So AD bisects BE. Actually, the way I drew this was not correct. Let me fix that. There we go. AD bisects BE. So that means that BC and EC are congruent. But we'll talk about that in a second. So that's the bit of information we're given, and we're also told that AB is parallel to DE. Yeah, so we've got that. Now here's the way we're going to prove this. Here's the way we can prove it. I could start up. First of all, I've got two sides here that are definitely congruent because I was given that. Now let's see what we can do with this. I know that angle C. Well, let me look at this. Let me write this. I know that angle BCA, this angle right here, is congruent to ECD. ECD. I know that. And the way I know that is vertical angles are congruent. I'll just do a shorthand there. So BCA is congruent to ECD. Okay. So now I've got that. Now let's see what else we can get. I know that these. Let me just look at this. I'm gonna say angle B is congruent to angle E. Yeah. In other words, I know that this and this are congruent to each other because the alternate interior angles are congruent for parallel lines cut by transversal. Okay? So I've got those two angles are congruent. Now, let's take a moment and think about this. This is what we have so far. Now, I want to draw your attention up here to this thing. Angle, side, angle. Look at this. Angle, side, angle. Angle, side, angle. It looks like to me that we have already proven what we need to. We could say this. We could say, okay, angle ABC, or triangle ABC, is congruent to DEC by angle, side, angle. There. So we have done what we were asked to do. Now, a lot of times in geometry, they'll have these two-column proofs, where in the left-hand column you'll make a statement, in the right-hand column you'll justify the statement. This is kind of paragraph form. It's a little less formal, and honestly, when in mathematics we usually use this form. It's paragraph form. But anyway, that's so you see how the game is played, and we'll do some more practice with that.